Kubernetes System Design with Spring Boot. Introduction. Kubernetes System Design is the process of designing scalable, resilient, cloud-native applications using Kubernetes orchestration and backend frameworks like Spring Boot. Modern enterprise applications use containers, microservices, Kubernetes clusters, Spring Boot APIs, CI/CD pipelines, cloud-native architecture. A common interview topic is explain Kubernetes system design using Spring Boot. This guide explains Kubernetes architecture, Spring Boot microservices, containerization, scaling strategies, service discovery, Ingress, configuration management, observability, deployment strategies, real-world architecture, best practices, production considerations. This is one of the most important topics for backend engineers, DevOps engineers, cloud engineers, and software architects. Simple definition. Kubernetes system design means designing distributed applications where Spring Boot services run inside Kubernetes-managed containers. Why Kubernetes is important? Kubernetes helps applications become scalable, highly available, self-healing, cloud portable, resilient, easier to deploy. Without Kubernetes, XX deployments become manual. XX scaling becomes difficult. XX downtime increases. XX infrastructure management becomes harder. High-level architecture. Typical Kubernetes architecture. Users, load balancer, Ingress controller, Spring Boot microservices, databases, cache, Kafka core, Kubernetes components. 1. Pods. A pod is the smallest deployable unit in Kubernetes. It contains one or more containers, networking, shared storage. Example. Order service pod at Spring Boot container 2. Deployments. Deployments manage pods. Responsibilities. Scaling, rolling updates, self-healing, replica management. Example. API version, apps, v1, kind, deployment, metadata, name, order service, spec, replicas, 3. Benefits. High availability, automated recovery. 3. Services. Services expose pods internally or externally. Types. Cluster IP, cluster node port, cluster load balancer. Example. Order service pods, Kubernetes service 4. Ingress controller. Ingress manages external HTTP traffic. Responsibilities. Check routing. Check SSL termination. Check path-based routing. Check domain management. Example. API example.com/orders. Popular Ingress tools. Check Nginx Ingress. Traefik AWS ALB Ingress. 5. Config maps used for external configuration. Example. API version v1 kind config map metadata name app config. Stores. Application URLs, feature flags, environment configs. 6. Secrets. Stores sensitive data securely. Examples. Database passwords, API keys, JWT secrets. Example. Kind. Secret. Spring Boot in Kubernetes. Spring Boot is commonly used for REST APIs, microservices, event-driven systems, cloud-native applications. Example. Spring Boot API. REST controller, @request mapping, :orders, public class order controller, get mapping, -ID, public order get order, path variable long ID, return order service get order ID. Dockerizing Spring Boot applications. Spring Boot apps run inside Docker containers. Example. Dockerfile. From Eclipse Temurin 21. Copy target app.jar, app.jar. Entry point Java, -jar, app.jar. Flow. Spring Boot app, Docker image, Kubernetes pod, microservices architecture with Kubernetes. Typical architecture. API gateway, user service, order service, payment service, notification service. each service. Check. Independent deployment, independent scaling, isolated failures, service discovery. Kubernetes provides built-in service discovery. Example: HTTP order service. Spring Boot services communicate using CUC, REST template, CUC, web client, CUC, OpenFAME, API gateway pattern. An API gateway acts as a single entry point. Responsibilities: check authentication, check routing, check rate limiting, check logging. Popular Java solutions: X Spring Cloud Gateway. Example: client Spring Cloud Gateway. Microservices, database design in Kubernetes. Databases are usually external or managed separately. Examples: PostgreSQL, MySQL, Oracle, MongoDB. Architecture: Spring Boot service -PostgreSQL database. Best practice: avoid running critical databases directly inside Kubernetes for beginners. Redis caching. Redis improves performance. Uses: session storage, API caching, distributed cache. Architecture: application Redis cache database. Benefits: SOC, reduce DB load, faster APIs. Kafka, event-driven architecture. Kafka enables asynchronous communication. Example: order service, Kafka topic, notification service. Benefits: quote, loose coupling, quote, scalability, quote, async processing. Spring Boot support. Check. Spring Kafka. Horizontal pod autoscaling. Kubernetes can scale automatically. Example: high CPU usage, more pods created. Benefits: better scalability, cost optimization. Example: kind horizontal pod autoscaler, rolling deployments. Kubernetes supports zero downtime deployments. Flow: old pods gradually replace new pods. Benefits: no downtime, safer deployments. Health checks. Kubernetes uses probes. Types: clearance, liveness probe, readiness probe. Spring Boot actuator endpoints. Actuator health. Benefits: quote, self-healing, traffic routing only to healthy pods. Logging and monitoring. Production systems require observability. Tools: check. Prometheus, Grafana, ELK Stack, Loki. Metrics monitored. Check. CPU, memory, response time, error rate. CI/CD pipeline. Typical deployment flow. Code commit, -build Spring Boot app, -run tests, -build Docker image, -push to registry, -deploy to Kubernetes. Tools: check Jenkins, check Hub Actions, check Argo CD. Security, best practices. Important security areas. Check. HTTPS, check. RBAC, check. Secrets management, API authentication, check. Container scanning. Spring Boot security. Spring security, OAuth 2, JWT. Resource management. Kubernetes supports resource limits. Example: resources, limits, memory, 512 MI, CPU, 500 millim. Benefits: CAP, avoids resource exhaustion. CAP, improves cluster stability. Fault tolerance. Kubernetes improves resiliency. Features: COM attack, automatic restart, replica recovery, rolling deployments, self-healing pods. Example: pod crashes, Kubernetes restarts pod, real-world example, e-commerce platform architecture users, top, load balancer, Ingress controller, Spring Cloud Gateway. Top, user order payment service, Backend technologies, area technology, Backend Spring Boot security. Spring security, messaging, Kafka cache, Redis database, PostgreSQL, containerization, Docker, orchestration, Kubernetes, monitoring Prometheus, deployment flow, GitHub push, Docker actions, Docker build, Kubernetes deployment, common beginner mistakes. 1. Putting everything in one service leads to monolith problems. 2. No resource limits can crash the cluster. 3. Ignoring health checks. Unhealthy pods may receive traffic. 4. Hardcoding configuration. Environment configs should use config maps and secrets. 5. Overusing microservices too early can increase complexity unnecessarily. Best practices: use stateless Spring Boot services. Externalize configuration. Use health checks. Use monitor everything. Use autoscaling carefully. Secure APIs properly. Use rolling deployments. Separate environments. Use centralized logging. Common interview questions. 1. Why use Kubernetes with Spring Boot? Benefits: Kafka, scalability, resilience, automated deployments, cloud-native support. 2. What is a pod? A pod is the smallest deployable Kubernetes unit containing one or more containers. 3. What is the difference between deployment and service? Component purpose: deployment manages pods. Service exposes pods. 4. Why use Kafka with Kubernetes? Kafka supports event-driven architecture, async communication, scalability. 5. How does Kubernetes handle failures? Using color health probes, automatic restarts, replica replacement, self-healing mechanisms. Sample Kubernetes system design. Users, Cloud Load Balancer, Ingress Controller, Spring Cloud Gateway, upper middle, Redis PostgreSQL, user service, order service, payment service, user service, Redis PostgreSQL Oracle, Kafka, notification service, monitoring stack, Prometheus plus Grafana. Kubernetes system design with Spring Boot enables scalable, resilient, cloud-native backend systems. Core concepts include: check, Docker containers; check, Kubernetes pods, deployments, services, Ingress, Kafka, Redis, Spring Boot, microservices, autoscaling, monitoring. Spring Boot and Kubernetes together provide: check, scalable backend APIs, cloud-native architecture, resilient deployments, automated scaling, production-ready infrastructure. Key idea: Kubernetes transforms Spring Boot applications into scalable, self-healing, cloud-native distributed systems capable of handling real-world production traffic.